All right, excellent. Welcome everyone. Welcome to our GDG Cloud Montreal May 2023 event. We'll just go through our classic agenda. Just let me actually share my slides so we can get going. Um, Dave, you just want to do a quick mic check on your side? Well, just making sure everything's okay.
Hey, good afternoon.
Excellent. So I'll switch the slides again, but not the same one. And we'll be good to go. So there's my big record button, making sure everything's okay. Um, and yeah, that one is weird. Let me stop sharing. I think I just shared the, I shared a Chrome tab. That's why it's so small. Let me share the actual window. Yeah, it's a bit bigger. All right. Yeah, just making sure I'm recording. Awesome. So like I said, welcome to our event for the month of May. So we're going to go through a serverless end-to-end journey from code to delivery and day to ops. So that's a lot. Yeah, the quick agenda item. Nothing. This is nothing fancy. Usually same agenda, just changing the title of the event and the date. So we're just going to go through some quick housekeeping. One of them is asking questions during the event, and then we'll have our main topic, and then we'll wrap up the May event. So I'm Stacy Verno. I'm Senior Pre-Sales Cloud Engineer at SADA, a Google partner. I have our faithful and most valuable speaker, I think coming up for the third time, David Sanders, who's going to intro himself a bit later. Thanks, Dave, for jumping in and going through this great topic. So just quickly, during the event, if you want to ask questions, you'll have, let's say on the right with the chat, you have like general, you have QAs, Q&A and DMs. So you'll have the QA section. If you want drop in questions in there, while we go through things, I'll act as the moderator, so I'll be able to check and also pass those questions along to David. So that way we can get your answers out. So simple as that. It's nothing fancy. And then that's the quickest intro I think I've ever done. So perfect. So I'll just directly pass it off to David. I'll stop sharing so you can actually start sharing on your side. Unless you want to let's keep that slide on and intro yourself on top of it.
10-second intro. David Sanders, I'm a specialist engineer focused on app dev, DevX, and serverless.
Perfect. So I'll stop sharing and then the floor is yours and just bring us through that serverless end-to-end journey.
Awesome.
Right.
I'm going to share my.
Yep.
Yep. I got
Excellent.
it now. I'm going to share my screen. Let me know when you can see it. All good?
All
Thumbs
good.
up? Perfect. So I'm not a slide guy. I like to get into the nuts and bolts. So very quickly we'll move into real examples. But this is what I want to talk about today and to share with you, which is Google's view on what a developer journey end to end looks like for serverless, but equally for GKE as well, for compute engine, for anything. We look at and let me turn my laser on. The developer's inner loop when they actually start to write code, to use Cloud Code, one of our open source tools, to use cloud workstations to securely develop their code. Here, replace cloud source repos with GitHub or Bitbucket or your tooling of choice. Today, I'm going to use GitHub when we actually do the demo, to then get very quickly to the outer loop, to be able to build securely, to produce packages, but also there should really be another arrow this way, to consume packages and dependencies. So I can do that securely, safely, efficiently, and effectively. And then be able to take those artifacts and deploy those. Today, I'm going to use Cloud Run as an example. but it could equally be Kubernetes. It could be Anthos, so it could be GKE on-prem or in another cloud. Coming soon, cloud functions and some of the other pieces, but then how to operate that on a day-to-day basis. So once I get to day two, how to actually be able to manage and run this platform. So let's come out of slides. You'll be glad to know I'm not going to do lots of slide decks. What I am going to do is to just slide my screen across. So apologies up front if it makes anyone feel a bit nauseous, because it can cause a little bit of motion sickness. I'll try not to do it rapidly like that. I'm a dev. I want to write code. I'm working on a project and I want to be able to work on this repo, which is in my repo and a private repo, but it's a demo app. So this is what I'm going to work on. But before I start working on this, I need to have a development environment. I could use, I'll just pull a prop. I can use my laptop, but the problem then is it's on my laptop. The code exists only on my laptop. It might exist in a repo here as well, but I've actually got the code physically, and I don't want to do that. I want to work securely. So the first thing we do, if we move back here, is look at cloud workstations. So cloud workstations gives us the ability to run a cluster of development workstations. And we very simply create a cluster. We can make it publicly accessible, or we can make it private so that it's only available through the VPC. We can put a service perimeter around the cluster to prevent exfiltration of data and code. And within that cluster, we can create configurations. So we can create configurations for, I'll look at the general developer, the fact that we give a set type. So here, an E2 standard 4, but I'll show you some of the other configurations I can use. The fact that we want the workstations to go automatically to sleep. So when they're idle, they'll shut down after 1 hour. I can add tags to the developer workstations. So if I'm using firewalls and tags, I can have values in here to actually control what the developer is and isn't allowed to do. I can disable public IPs on the developer's workstation. And you can see in my example I have, and then I use Cloud NAT. I could also use Google's Cloud Secure Web Proxy. So not only can I NAT the traffic and protect what's going egressed from my developer workstations, if I bring Secure Web Proxy into play at layer 7, I can actually say, yes, you're allowed access to do a get or a post to github.com, but you're only allowed to access this path or whatever the filter is. So I can actually restrict it down to external access, even to a project level with Secure Web Proxy. I can run a confidential VM. I can enable secure boot, VTPM, and integrity monitoring. I can do encryption. I can either use Google managed encryption, or I can bring my own customer managed encryption key. So those workstations, whether they are in use, in transit, at rest, are encrypted end to end. And then everything is based around a Docker image. So I create my image to actually provide the environment. I can run the workstation under an initial identity, and I can provide persistent storage. So I can actually say, okay, 200 gigabytes. When you delete the workstation, I can either retain it or I can delete it. So if I want to retain it for audit purposes, I might retain it, snapshot it, and then put it somewhere else. And I can do various configurations. Just very quickly, I want to show you the type of configuration I can do. I can do quick start, which always keeps resources ready. Developers can sign in within seconds using Quick Start. If I disable it, then my machine is provisioned for me when I request it. But here's what I want to show you, the different types of machines that we support: E2, N2, T2D, N1. And then if we choose a machine, let's choose N actually, because it's, I can go all the way up to 32 core, 128 gigabyte machines. So rather than have to try and find a laptop that's able to deal with that, I can provision a workstation. I can assign it to a user. They can actually sign in, use it. When they're no longer using it, they can, it will close down automatically, or they can close it themselves. So when I look at my workstations, I actually get the view here that shows me if I'm an administrator, which I am, all the workstations, or just my workstations that have been assigned. And even though I'm an administrator, if there were other workstations here, I would not be able to SSH into them or connect to them. But here, if I actually want to run this in a browser, I hit launch, and I'm running, in this case, Visual Studio Code, or Code OSS rather, but VS Code. I can also run IntelliJ, I can run PyCharm, and I actually can work in the browser and do absolutely everything that I'd expect to do. So this is my demo app, and it's just Visual Studio Code. Everything that I'd expect to be able to do and see, to look at the Docker file for this app, the cloud build, the Python code, everything that I need to do, I can do. I can even hit Control F5. Let me just run this. It's run on Cloud Run Emulator. And this is going to spin up Minikube within my workstation. Now, I've already spun up Minikube, so it's already running. Yes, I want to use authentication. Let's just lock that so we see the updates. And now it's actually starting the deployment. So it's deploying my application on Cloud Run Emulator. So within my inner loop, very quickly, I've been able to actually get up and running. But I'm in a browser here. So what's going to happen if I try and follow that link? Let's just click. Let me zoom in here, because this is important. It's actually handled the redirection for me. It's given me a secure, certificate-backed, IAP, identity aware proxy protected redirection to my application. So this is my app running in the browser, running from VS Code within the browser. If I wanted to run in debug mode, I could run in debug mode. I could set breakpoints. Let's choose somewhere a bit more interesting. I could choose a breakpoint. I can choose watches. I can do a full debug session. And all of this has happened from within cloud workstations. So rather than have to run on localhost 8080, Cloud Workstation knows that we need a redirection, and it redirects for us automatically. And this is the app I'm going to show you today. It's a simple app that takes me through identifying the user that's called the app, identifying the service information of where the application is running, and just some general other tests. I'll come back to some of this in a moment or two. The other part to keep an eye on is this piece at the top. So here, I'm currently running this in local. So I am running it in dev mode, but I haven't gone to the official dev environment yet. This is our sandbox. And then I'm going to progress through test, a review, before finally releasing the review through production. So this is great. I'm working in the browser, but actually there are some things I don't like about a browser. So what I want to do now is to just, let me stop that. So Minikube is going to get shut down. One thing I'll show before I leave this screen, I can also run on Kubernetes, which will run on Minikube. The Cloud Run emulator runs on Docker. And I can also deploy all from the browser. Everything that I would expect to do, I can look at Cloud Run. I can look at my apps for the project that I'm using, and my project is set down here. Everything lets me stay within this dev environment within the browser. But I'm actually going to close that because what I want to do is to actually run this locally within VS Code. So one of the things I'll actually show is I can connect using SSH. So I can actually set up an SSH session straight from the console, or I can actually do port forwarding. And here I can say port forward 22 to 2322. And I get the command to actually start a tunnel. Now I've already done this, but what this lets me do is to now actually run VS Code. So if I go into my demo app, and I'll just clear that, it's VS Code. I'm running locally within my machine. You can see all of my Mac controls. It's just VS Code. So again, if I'm in app and I want to run it, I'm going to hit Control F5. And again, we're going to run it on the Cloud Run emulator. And so now it's going to unpause Minikube. It is going to ask me, do I want to enable authentication? Yes, I do. So I've enabled auth. It's configuring the add-in, and the project will start in a moment or two. Now, what happens when I'm running this locally is that VS Code and the Cloud Code plugin automatically adds a port redirection for me as I need it. So it redirects from the cloud workstation to my local workstation. So now when I hit Command click, I get exactly the same. My app opens in the browser. I get the ability to go and run it. Now, let me go back to VS Code. The next thing I want to show, if we go back here, is the cloud code and actually being able to use, maybe that link should come that way, being able to use packages securely. So within my dev team, we have set up a repository. Let me just go to the correct window, whereby all of our Python packages are actually held within artifact registry repositories. So if I look at my Python helpers, I can see my Python packages like metadata. I can see the various versions of my package. Now I'm using Python, but the same applies to NPM, to Maven, whatever your environment is. And so here, I'm storing my packages securely. And I can use for Python, I can use Twine, I can upload, I can get the correct packages directly from the environment. And let's show that. So I've gone to a workstation, and again, I'm SSH'd into this workstation, but this is my cloud workstation. So now, if I do pip install requirements.txt, and I'll do an upgrade, I'll let this run, and then I'm going to point things out as we go. So notice my indexes. My indexes, the way I've set up my workstation and configured my workstation is to allow PyPy, but to have the first index set to my private packages. So this way, if there are things that I don't want to publish to everyone in the world, I can get them from my private package. But I also have a group repository, which allows me to get not just from my private packages, but also from PyPy. So I can actually get internet based packages as well. And you'll see, let's see if I've got anything downloaded. So Flask, you'll see that I've actually downloaded it from my private virtual repo to PyPy. That way I get to control and see what's actually being downloaded in my environment. On our roadmap, we do plan to bring in scanning and more granular access control around these dependencies and these packages. But this way I can tell exactly what's being downloaded from PyPy within my environment. So it gives me a benefit to keep going. Stacey, I wanted you to do a check because I saw a Q&A.
Yeah, I saw
You are
somebody
still
says,
here.
yeah, yeah. So is the session still going on? So like, I'm guessing it is. So, but it's like the
And
is
you
it
can
the
see my screen moving.
workstations? Oh yeah, yeah, 100%.
Okay, perfect. So from this piece, I'm now getting my dependencies from Artifact Registry and bringing those into cloud workstations. And so this is great. We will, if we've got time, I'll show some of the configuration around the workstation. But now, as a developer, let's make a change. I want to change this to say GDG. Okay, let's actually check this. Let's just run it in Python locally so that I don't have to start up Minikube. So I'm running it in Python locally. I'm going to open in the browser. Yep, perfect. We have our change to our application, and we can now go and commit that, do a merge or a pull, get the merge approved, and then it will fire off this trigger. So let's go back to VS Code. Let's stop the application, and let's and I'm going to commit and push. And my inner loop is now complete. I've really done everything that I want to do. So now what I can do is actually see my trigger and actually follow the build. So what we're doing now is we've actually jumped to cloud build. So I've done my push and merge, and I've triggered my cloud build trigger. So now I'm doing continuous integration. And these are the kind of typical things. This is queued and waiting to run because I'm using a private build pool. Let's just quickly show that. I use a private worker pool so that I can securely build my images without using shared infrastructure. So by default, when you build with Cloud Build, you build in the default pool. What I've done is I have defined a pool and I've also connected it to my VPC network. So now I still allow it to access external IPs. I could actually use internal only and force everything to go through my proxy. But now I can define the type of machine that's going to be used for running my builds and executing my builds, where it is, and so on. So let me just close that. So now my build is starting. So I'm going to go through a number of things. I'm going to do my dependency install. So here I'm grabbing my dependencies into Cloud Build. And again, I'm using my private, if I just pause this for a second, you'll see I'm using my private repository. I'm not using an internet-based repository. When I've installed my dependencies, I'm going to do my unit tests. I'm going to security scan it, and I'm going to lint it. And at this point, These are the things that I should do as good practice. And where this comes from, where this pipeline comes from, is my cloud build file. And my cloud build allows me to run a number of steps in parallel or sequentially, and to I use substitutions, so I can actually provide key information. I may use a different worker pool for different applications. I can go and get secrets. So within Secret Manager, I store some key information like my IAP client ID password. I have a key that's used only to access Artifact Registry, a specific service account. And I also have my GitHub Pat token. These are things I don't want in my build. So at this stage, I don't want anything contained here or even here that relates to a secret. So here, I go and get it from Google Secret Manager. And then I can start going through my steps. I can make some substitutions. I can do a full clone. The reason I do a full clone, and here's the reason that I need the GitHub Pat token. The reason I do a full clone is so I can do a git log and actually get, sorry, a git rev parse, and actually get the build version, so the last commit number. Then I get my dependencies. Then I do my security scan, and so on and so on. I can go through all of the steps within this piece. And you can see we're at step 16. We're just about done. There's a couple of things that I'm going to call out. One, I do some interpolation, and this is a bug in Cloud Build, so bear with me. I do some interpolation so that I can actually substitute variables within my YAML manifest. So YAML doesn't support variable interpolation, so I've built my own approach using Jinja 2. This is going to be this is going to be made a lot easier in Cloud Deploy, which is where we're going to next, around making this more simple. But what I do is I start a deployment. So within Cloud Deploy, once my build has completed its various stages, I actually have a pipeline. And this is Cloud Deploy. I define a set of targets. So I have a dev project, a test project, and a prod project. This is region 1. Again, just released, we're actually supporting multi-target pipelines, but this is an old style one region per pipeline. And I also have a second pipeline, which is identical, which is in Montreal. So if I look at these targets, I can tell what was last released, when it was released, the description of the release, and a link to the target. But I can also get, remember my git commit was add GDG Montreal to heading. So that's what I use as the description for the release. And if I look at the release, I can see the rollout. So far, I've only rolled it out to dev. I can look at the artifacts that were generated. So I can look at the build artifacts, security insights, but I can also look at the render logs. So I can look at various pieces of information. I can also look at key annotations that I can pass. So some of the annotations I pass are blame. So who's to blame? Who actually caused this release? And then the build ID, the commit SHA, and I can even embed links. So I can click on this link and go to the source code. Oh, that didn't work. go to the source code at the point in time that the build was released. So in this way, I actually have a ability to drive a pipeline. So now, if we look at this, I'm going to grab a link from another window. Please bear with me. I will just quickly change to a different, and I'm just going to run a Terraform output to get my link. Everything that I do in this demo is backed by Terraform. So let me just click on this URL. And now I'm actually running in Cloud Run. So again, if I go back here, Cloud Deploy has actually published that to Cloud Run. So now I do know the identity of the user, because if we open this in an incognito window, I actually use IAP. So now I'm actually signing into my application. And because I'm using IAP, I need to use my second form of authentication. So I'm going to hit my button, click next. And now I've actually signed into the application. So I've taken advantage of the platform to use, excuse me, to use identity aware proxy. And now I can tell who the user is, but I can also tell that the user identity was signed by Google, so that this is a valid user identity. When you're using IAP with Cloud Run or with GKE, you want to always verify that in the header, xGoog authenticated user email should be signed by Google. And we can check that with a really simple call out to a client library function. Again, this is Python, but it could equally be Go, Java, or Node. And I can make calls out to that library to actually verify the token. Notice as well that instead of being local now, I'm now in dev. Awesome, right? So I've actually started to progress along dev. So Stacey and I are working on this together. We've been running it. It looks really good. We're ready to go to test. What's our next step? We go back to Cloud Deploy. We can simply hit promote. I can do, in this case, in my example, I only have a stable rollout, but we also support progressive or canary rollouts. So I can actually say, I want to do a 25% rollout. I want to be able to actually test this before I go, before I go any further. I can also look at what's happening with the release. So again, I can look at who's to blame. I can look at the IDs. I can look at the source. I can look at the Git log, the commit message. Big benefit though is I can look at the difference between what was there before and what's here now. And in this case, the latest release to target was nothing. We hadn't actually released it to the target before. So I am going to promote this to test in region 1. So now I click promote. This will then go and deploy it to Cloud Run. I'm also, because I have multiple regions, going to promote this in region 2. Now, the new feature that we have around multiple target releases allows us to actually pull that together in one pipeline. But the way I have this one set up is a single. So now I look at my deployment. I can view it. I can follow what's happening. I can actually go and look at the artifacts that have been generated. So the scaffold file that was generated to run, or the manifest for Cloud Run that was generated. So here, good example, you can see I set private ranges only for VPC connector if you've used Cloud Run before. So I can see the assets that have actually been generated and the environment variables that have been populated. I can also look at the logs as it actually runs the deployment, and I can follow through exactly what was done to deploy this application. In this case, to Cloud Run, but again, equally to GKE or to Anthos. So let me go back here now and go to test and go to the test URL. And now I'm in test, right? So I'm in my test environment. If we look at the two, you'll see there are differences around the instance ID. You can see those changes I flick, but also instant changes around the audience. So when I validate the JOT token that's passed here, I use the audience to actually verify that it was signed by Google for this application. So you'll see that changes and is different. You'll also see that my version is the same. So if I look at the version, so it's consistent across the apps. I'm running in North America Northeast 2, and I'm running in North America Northeast 2 for the app as well. And that's what I was looking for, dev and test. So I am changing. So this is awesome, right? And so we are in this loop here where we're actually going through our cycle. We've gone through dev, we've gone through test. Now our manager and our users have gone through and they say, it looks good to me. So let's release it. So now if we go back to the pipeline, I can promote from test to production. Release of new features. Again, I can do a canary. I've only got this set up to do stable, but I'm going to promote it and send it back. Or not send it back, and move it into production. Let me do the same for the second app as well. I won't do a description. I'll just promote. But I'm going to pause once the screen comes up just to show you that actually I'm pending review. Now, with RBAC controls, we can say that someone has the permission to promote a release, but not necessarily the permissions to actually review the release. And again, when I hit review, I can hit it here or here. I'm actually going to see that it needs approval. I can see the release and the create date, and I can see all of the same information. So I can see exactly what we're going to do, and also I should be able to see the manifest difference there, but okay. And then either approve or reject it. And it's only if I have the right permission to approve will this actually start its journey towards production. And again, the same if I go to the second region. Obviously, I did second region rather than first. Review it, and I'll just approve it because I've already looked at it. Stacy, I just want to do a quick time check.
Yeah, well, you still have like, if you want to finish out one, we still have 15. If you need 20, we can do 20.
Perfect.
Not a problem. I think
Perfect.
you have
15 will be good.
excellent.
So now I'm rolling out to production. And so again, let me click on the production link, and I'm in production. So I've now gone from local through dev through test, through review, and into production. So everything is working exactly as intended. So this is awesome. I've now gone through a managed pipeline, but that's assuming that everything works incredibly well and everything's great. But there are things that I might do, like make a change. So something that's not going to cause my app to fail, but actually I've changed Montreal to be English spelling rather than French, and I'm going to commit it, and we're just going to say change Montreal to English spelling. I'm going to commit and push. So now we're going to go back to our continuous integration, and we're actually going to run through CI. So this takes about 3 minutes. So while we're waiting for that, what I'm going to show you is the ability to either redeploy or roll back a release, because things don't always work well, right? So in this case, the scenario, we've committed our code, we're running through the cycle, and maybe we didn't actually notice it all the way up until production. But it's 5 to 5, it's Friday. Stacy and I are supposed to be going for beers. I want to be able to roll back a release and to roll it back quickly and safely. So we've built in the capability to actually choose successful releases to roll back to. And it's very quick. Let's actually do it with this one before I. So let me roll back to 650, and then we'll go to the dev environment. So I've kicked off the rollback. If I did it in production, I would still go to a review cycle. But now I'm actually rolling back from, remember, we're on 652, and we actually want to roll back to 650. So let's cloud deploy. So we're now actually doing that rollback. And you can see we're not creating a new release. We're not creating a new revision for Cloud Run. We're actually rolling back specifically to that revision and release. And we're now done. And if I actually refresh, now there's no GDG Montreal. I am on version 06.50, and that's awesome. I've cured the problem. When my build finishes, which it just about is, and it will go through the steps, we'll come back there. This will then trigger the pipeline again, and we'll roll out version 653. So let's come back to that, because now we've gone through Cloud Code. And in fact, one last thing before we do that, let me go to Cloud Code. When I'm in Cloud Code, I can actually stay as a developer in, there's two things that are probably worth showing here. I can actually stay within my IDE. I don't have to go to the console. I can look at the logs. I can look at the run and revision. I can look at the properties associated with it. If I click the logs, it's going to go off and actually bring the logs into my IDE. If I want to do it through Cloud Run, I can go into the dev service and look at the logs at an individual application level. So I can see all of the logs that are related to my application, which is awesome, but I tend not to work on just one application at a time. And it really is a pain to have to go into, okay, which one do I need to go into? Was it this one? No, it's not. So it takes extra toil, and we don't like toil. So instead of having to go to the application or the Cloud Run service, I can actually jump to Logs Explorer and actually look at this at a detailed level. So I can say, only show me the Cloud Run pieces. I can also start to do queries and say, and resource dot labels dot, let's see which, let's just pick that one. And I'm only doing that to make it easier. Revision name, and then run this query, and then only get the logs for that service. So this makes it really easy for me to actually start looking at things from a central perspective, because typically I'm not going to look at each individual service. I can also say, only show me the warnings. So there's only been one warning, so let's see what the warning was. A 404 error. So I'd obviously tried to connect before it was ready. And so I can get this log information, and I can be really effective with my queries to actually help me figure out the right information that I'm trying to find. Now my build is finished. So let's go back to our dev environment, refresh. So Stacey's just phoned me up and said, "Hey man, what are you doing? That's not how we spell Montreal. Can you change it for me, please? It's 5 to 5. It's Friday. I'm done. I'm ready for the weekend. It's been a busy week." What I do, actually, just before I do that, notice in test and prod, because I haven't promoted this release through the cycle, I don't have that impact in prod, but in dev I do. So now I can go back to Cloud Deploy. You can see we're on 653, and I can say, no, roll back to 652, which was the correct Montreal. Again, I can look at the differences. I can look at the releases different, but also the environment variables that are different, and my revision name that I'm going to bounce back to. So let me roll back, and we'll then cover one last area on the chart. So we're now rolling back. This will take a minute or so, but we've been able to go, let me just bring this up in slideshow for a second, from cloud workstations with cloud code through our source code management system, GitHub in my example, and through continuous integration and build, using managed artifacts, both as a store, but also as a provider of package dependencies, being able to use Cloud Deploy to deploy, in our example, to Cloud Run, and to manage those releases and roll them out to target environments as required, rather than at once or imperatively. We looked at cloud logging. We'll touch on cloud monitoring. But the other thing I want to touch on, let me just refresh. And we're back to the proper spelling of Montreal. So it's very, very easy. I can put role-based access controls around all of this piece. I can control who can do what, where, and when. The final thing I want to show is tracing. So within my application, I actually have tracing enabled by default. Now, I haven't done any customization here, so it's a little bit boring, but this is open telemetry. So I can use OTel to actually add spans or events or information to my requests. I can pass the context so that I can have distributed tracing. And I get to a point where I can see my outliers very closely and clearly. So if I zoom in here, I can see the range of my typical latency for requests. For my demo application, that's okay. I expect it to be 2000 milliseconds because what it's trying to do is actually connect to Redis. And I don't have Redis stood up at the moment. I do have a certificate. I do have the secret. I have used Google Service Directory to discover the Redis endpoint. Um, but the Redis instance itself is not currently running, which is why I can't ping, get, and set the Redis instance. So this gives me great power across this whole journey, but it also gives me speed. It gives me security. I can use cloud workstations, which are, let me show that actually very quickly. Configured based on a Docker file so that I can prepare everything that I want the developer to be able to use. I can install things like Helm. I can install kubectx. I build a Docker file for that workstation. So now, as a developer, if I try and do a sudo, hey, you're not a sudoer, right? So I've got the ability to control and customize this workstation. I can use cloud workstations with out of the box containers, but in this case, I'm actually customizing it. I can make customizations to things like profile.d, but also to my PyPyRC. So here's where I'm actually setting the repository and so on. So we're able to move all of the way from cloud code, cloud workstations, into our repo, into cloud build for CI, into cloud deploy for CD, with our packages both in development and in CI provided by Artifact, Registry, and secured, and then able to be deployed to Cloud Run or Kubernetes, and also to actually operate and manage the environment. Again, monitoring is the same. I can look at monitoring on an individual level, or I can use the monitoring dashboards to get information across my portfolio. At the service, this is what's happening during that service. But if I look across the portfolio, the scope of projects, then I can see it for a number of services. Stacy, that is me on a whirlwind end to end. Is there anything you think I've missed? Were there any questions? Or have I just bamboozled you all with my Scottish brogue?
Or all of the above. No, I mean, like, in terms of Q&A, I have, like, there's nothing. So there is there was a lot to go through, but it is actually, I have one question. Maybe I've asked that
Yeah,
before, around workstation. Is that something that's going to be available in Canada, or is it already?
it's on the backlog. It's not available in Canada at the moment. So today, let me show you here. So if I create a cluster, today we support South America, Central 1, East 1, East 4, West 1. It is on the backlog to add North America, Northeast 1. But today we don't. We also support Asia Pac, and we support Europe and the Middle East. So those are the locations. The way I know location can be an issue for some. From a code perspective, everything is code, right? So when I actually use cloud workstations, I don't have, or I shouldn't have, local data actually here. Let me just change that back before I forget. And so I shouldn't have any data in here. I could run a MySQL instance or something, but again, I probably shouldn't. The idea with cloud workstations is that I'm able to link off to everything. So if I look at my resources, and I didn't actually create a Redis instance, but if I did create a Redis instance, then it would have been created in North America, Northeast 1. But I've got this disabled at the minute.
Yeah. No, just like in regards to, I don't know, like to your point, like if within my environment, which actually is a compute with a disk attached, making sure that this stays in Canada. Just but if it's in the pipe, it's good. I mean, that's what we want. Also, as well, just plain latency, depending on where you are. Having it closer to home is always nice. But the feature itself is as a service, it's great.
It is from a latency perspective. It's really interesting. Let me just go up my workstation in the browser. I'm in Kitchener, right? I don't have the greatest home broadband, but the performance on cloud workstations to US Central is really, really effective. It's really good. So I can actually work on the browser if I wanted to very easily.
Here we have a question from Ludovic. It says like, what about cost for workstation per user on a daily basis for a full stack developer?
Okay, so the cost model for cloud workstations is based on a cluster management fee. This is actually Kubernetes behind the scenes. You don't use your quota, you don't have to manage it. We do all of that for you. So that's where the management fee comes in, right? Because we're actually running Kubernetes to manage. When we spin up a workstation, though, what actually gets spun up is a virtual machine. So the virtual machine is managed by the control plane on Kubernetes. You notice I have no external IP. I can, if I can reset my screen, SSH to that VM, but my actual workstation environment is running as a Docker process. So it's running in Docker within that machine. So I also get charged for the machine on a developer basis and the persistent disk, sorry, this one, that goes with the developer's workstation. So in terms of charges, those are the main things. Egress would be another thing to consider. It can work out, it has to be calculated, but typically between 50 to $100 per developer. Again, it depends on the type
Per
of
month.
machine. If you're per user, per developer per month, yeah,
Okay. Yeah.
roughly.
Yeah. Okay. So Ludovic, anyway, like I was looking also at the same time at the GCP calculator. And
Yeah,
then cloud workstation is there. So depending on the type of provisioning, the machine type, the number of like the RAM, whatever you want, like you'll actually get
the
a
sleep
good idea.
time. Yeah. And the other thing that I like about cloud workstations is sleep time. So I can actually go, let me just open that. So when I'm calculating the cost, I thought sleep time was, here we go. Bum, 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 bum. It was when I looked the other day. Anyway, if I have sleep time set to an
It was there
hour,
on mine actually.
was
It's
it?
somewhere.
Maybe just I'm not seeing it.
It says like
So
1 by default or something. So
yeah, it should be 1 hour. Um, okay, well, you get the idea with the calculator. But I can actually set the sleep time to optimize costs. Because if a developer walks away, um, when they come back and their machine has gone shut down because it's gone to sleep because they were away for 2 hours, they just restart it. So they come into their workstation page and just start, and then everything's there. Everything's persisted. Their home directory is persisted. And so they don't lose anything. If they're in VS Code and they've started a new file and they shut down, as long as they don't close their window, when they bring their VM back up, they'll be able to save that file. And folks, that's it. So Stacey, at this point, I'll pass back to you.
all good. Just FYI, yeah, with the link of the calculator that I've put there. So when you click on it, you're technically on the cloud workstation icon, but you're not. So you're actually in compute. That's why you didn't see the sleep 1 hour. So
that
maybe report that back to the mothership. Uh,
I will indeed.
but so when you click on it, you can actually see the like the hour use per developer a week, and then you can set up your auto sleep period, which is going from like 30 minutes to 4 hours. So yeah, you're able to do that. So let me actually share my screen again one last time, and we'll wrap things up. All right. So actually, hey, we're back. We're back with a wrap up. So I just want to thank you, David. Again, thanks for a great talk, great topics. Again, like for everybody, everything is well. We've recorded the entire event, so this will end up in the event page directly. So you'll have the link to YouTube directly from there. So future events, we actually have one, and the date may change, but it's still going to be in June. So we've been talking about like pipelines. We're talking about security, and in every of those options, like there's always a database somewhere. We never kind of zoomed in on actually the database offering and the way they work within GCP. So we'll have Rogerio, who was with us, I think, at the end of 2022. Um, so he's gonna come and talk about the database offering, the way they're set up, resiliency and all that. So far June 21st, worse is gonna be like June 28th, the week after. But just keep an eye out for the event. As soon as we have like the micro agenda and everything, we'll put that online, and you'll be able to RSVP. So again, just quick reminder, you can join us on Slack. We have a public Slack channel for the GDG Cloud Montreal. So it's channel GDG Cloud Montreal public. You can use the tiny URL or the QR code. Since this is recorded, you can play it back and make sure you have the URL handy. If you have the time, we like some feedback, so you can visit our that little form that's hosted there, so you can give us some feedback, and let us know what you want us to talk about in the future. Of course, uh, from the intro slides, there's always like the call for speakers. So if you want to actually talk at this event, you can reach out either through the form. You can ping me on LinkedIn. More than happy to have customers talking about their stories and the way they're doing things around a specific topic. So when it comes to GCP, so just feel free to reach out. And yeah, that basically wraps it up. So again, thanks everybody. Thanks for being with us today, and then we'll see everybody back in June. So in a month, we'll be back for more. Thanks again, David. It was great.
Thank you for the opportunity. Cheers,
Pleasure.
everyone.
All right. Thanks, everyone. Bye bye.
Bye.